All right, everybody, welcome back for another deep dive. Today, we're going to get into some really cool stuff about how our bodies burn fat.
Yeah, we're going to get into the nitty-gritty today.
Exactly, the real nitty-gritty. We're going to be using this YouTube video as our source material today. It's called Exercise, Epinephrine, and Lipolysis of Stored Fat.
Catchy title.
It is, and it's from the channel Metabolism Made Easy, which, I love.
Yeah, great channel.
So we're going to be exploring basically how our bodies unlock stored fat for energy. And this video, it really gets into the weeds, which is what we love to do, deep dives.
For sure. I mean, we all know that exercise helps us burn fat, but I think a lot of people don't really understand the mechanisms behind it.
Totally. And that's what we're here for today. We're going to break it down step by step.
Absolutely. So I guess the first thing to understand is the role of epinephrine.
Okay, epinephrine, also known as adrenaline, right?
That's right.
So most people think of epinephrine like fight or flight, right? You see a bear, your heart starts racing.
Exactly. It's that rush of energy that helps you respond to a threat.
Right. So what does that have to do with burning fat?
Well, it turns out that epinephrine plays a key role in how our bodies utilize energy. And this includes both exercise and fasting. Both of those things can actually cause epinephrine levels to spike.
Oh, interesting. So it's not just the fight or flight response.
Nope, it's much broader than that. When epinephrine levels increase, it triggers a cascade of events that ultimately leads to the breakdown of stored fat.
Okay, hold on. I'm already getting lost. Breakdown of stored fat, what does that even mean?
Well, basically, we have these fat cells throughout our body, adipose tissue, as it's called.
Right, the stuff we're always trying to get rid of.
Well, yes and no. Fat is actually an essential energy source for our bodies.
Okay, that's true. I mean, we need some fat to survive, right?
Exactly. And when we exercise or fast, our bodies need to access that stored energy.
So that's where the epinephrine comes in.
Right. So think of it like this. You have these little storage units all over your body, the fat cells. Each of them is full of energy just waiting to be used.
Okay, I like that analogy.
And epinephrine is like the key that unlocks those storage units.
Aha, so epinephrine is like a key. But how does it actually, unlock the fat?
Good question. So epinephrine, it binds to a specific receptor on the surface of the fat cell.
Receptor. Okay, like a lock on the storage unit door.
Exactly. It's called the beta-adrenergic receptor.
Beta-adrenergic receptor. Got it.
And when epinephrine binds to that receptor, it sets off a chain reaction inside the fat cell.
Okay, so it's like sticking the key in the lock and turning it. Then what happens inside the storage unit?
Well, think of it as a domino effect. Once epinephrine binds to that receptor, it leads to an increase in something called cyclic AMP, or CAMP for short.
CAMP. Okay, and what does CAMP do?
CAMP activates another enzyme called protein kinase A.
Protein kinase A, another big word.
I know, but bear with me, it'll make sense in a second. Protein kinase A then activates, or switches on, you could say, yet another enzyme called hormone-sensitive lipase.
Hormone-sensitive lipase. So we've got a whole cascade of events happening here.
We do, and this hormone-sensitive lipase, or HSL as it's often called, is the real star of the show.
Okay, HSL, the star. What makes it so special?
HSL is the enzyme that actually breaks down stored fat, which is called triacylglycerol.
Triacylglycerol. Okay, that's the stuff that's actually stored in the fat cells, right?
Yes, exactly. HSL breaks that down into smaller molecules, fatty acids and glycerol, and releases them into the bloodstream.
So it's like once HSL gets activated, it goes into the storage unit and starts chopping up all the big pieces of furniture so they can be carried out the door.
That's a great analogy. You got it.
So these smaller pieces, the fatty acids and glycerol, they're the ones that our bodies can actually use for energy.
Precisely. They get transported to different tissues in the body, like your muscles, where they can be burned for energy.
So that's why after a good workout, even though I'm tired, I also feel kind of energized?
Exactly. Your body has just unlocked and released all these energy-rich molecules into your bloodstream. It's like a fresh supply of fuel.
Wow, that's amazing. I never really thought about it that way before.
It's pretty incredible when you think about all the complex processes that are happening in our bodies all the time.
It really is. So let me ask you this. If epinephrine is this, key to unlocking fat stores, does that mean there might be other ways to activate this whole process? Besides exercise or fasting, I mean.
That's a very good question. And to be honest, that's something that researchers are actively exploring. I mean, the potential to influence these pathways to essentially find other keys to unlock those fat stores is a really fascinating area of study.
It really is. It makes you wonder if there are ways to, hack our metabolism or something.
Well, I wouldn't use the word hack, but yes, there's a lot of research being done on how we can manipulate these processes to improve our health and well-being.
That's really interesting to think about. Well, I don't know about you, but I'm feeling a lot more knowledgeable about how my body burns fat now.
Me too. It's always amazing to delve into these complex biological mechanisms.
It is. All right, so for our listeners out there, if you've ever felt that rush of energy after a workout or even after a period of fasting, now you know the science behind it.
And who knows, maybe someday we'll be able to tap into those fat stores even without breaking a sweat.
The future of fitness. Thanks for joining us on another deep dive.
Thanks for having me.
We'll see you next time.
See you then.